Hello and thank you for joining me. My name is Francis and I'll be taking you through a lesson in geography in which we'll be talking about volcanicity. And you might ask why volcanicity? This is because volcanicity is one of those internal land-forming processes that has played a very big part in shaping our planet. And it continues reminding us of how active and dynamic our world is. And the sooner we understand the processes involved, the better for us, even as we strive to make this planet a safe place for humanity. Here's a picture of Mount Kenya, which is the second tallest mountain in Africa. Its summit is at an elevation of about 5,200 meters above sea level. I have it here because the mountain was formed as a result of volcanicity, and I also find it as one of the most magnificent mountains on our planet. By the way, volcanicity has also been observed in other planets. This picture on the right here, which I got from NASA, is of Mount Mons, the highest volcano on planet Venus. And therefore, volcanicity is not only responsible for shaping our planet, but the entire universe as we know it. Before we dive deeper into details about volcanicity, let's look at definition of some key terms, starting with the term volcanicity, which can be defined as a process through which gaseous, liquid, and solid materials are intruded into the Earth's crust or extruded onto the Earth's surface. A bit of a wordy definition there, but as you may have noted, there are two main things that we can pick out from it. One is that we are talking about materials, which can exist in any of the three states of matter: gaseous, liquid, or solid. And the second thing to note is that these materials can either be intruded into the Earth's crust or extruded onto the Earth's surface. As illustrated in this diagram here, you can see that the materials are beneath the surface of the Earth and they can accumulate in such a magma chamber. We need to note that it's really hot down here, and the materials are under great pressure, meaning that they'll always be looking for a way out. And on the way out, they may either cool and solidify inside the rocks or within the crust of the Earth, forming what we call intrusive volcanicity, or they can manage to reach the surface of the Earth, resulting to what we call extrusive volcanicity. The second term to define is magma, and this is molten rock found beneath the Earth's surface. This hot boiling liquid inside this volcano is what we are calling magma, and this was taken in one of those active volcanoes in Hawaii. Magma can reach temperatures of up to 1,300 degrees Celsius, and it's mainly formed through the melting of rocks of the crust of the Earth at various settings, including subduction zones, mid-ocean ridges, and hotspots. And it's later stored in magma chambers. If magma forces its way to the surface and reaches the surface, then it's called a lava, and this lava can flow very quickly and for long distances depending on its viscosity. Lava will actually destroy everything in its path. Therefore, the distinction between magma and lava is all about location. When geologists refer to magma, they are talking about the molten rock that is still trapped underground. And if this molten rock makes it to the surface of the Earth and it keeps flowing like a liquid, it's called lava. Despite volcanicity being one of those most dangerous and destructive forces of nature, it's also responsible for the formation of those magnificent volcanic mountains that we really enjoy looking at. I'll leave you there for now, but I'll leave you with a clip from National Geographic that I'm certain will enhance our understanding on the study of volcanicity. See you in the next lesson.
Portals into the heart of the Earth, they burn. Bottomless cauldrons fueled by an ancient wrath, bubbling and boiling thousands of miles beneath the surface, and just waiting to burst through. Volcanoes are scattered across the planet. About 1,500 active volcanoes can be found across the world, though countless others are on the ocean floor. Most volcanoes, whether on land or underwater, are located where tectonic plates meet. In fact, the Ring of Fire, a path that traces the boundaries between several tectonic plates around the Pacific Ocean, contains about 75% of the planet's volcanoes. There are several types of volcanoes, primarily classified by shape and size. Major types include stratovolcanoes, which often appear as tall, steep mountains; shield volcanoes, which are flatter and dome-shaped; calderas, which are large depressions in the ground; and mid-ocean ridges, which are underwater chains of volcanic mountains. No matter their shape or size, all volcanoes emit gas and molten rock. The journey of these emissions begins deep underground in the Earth's core. The core, which can burn as hot as the surface of the sun, transfers its heat to the surrounding rocky mantle. In doing so, the heat melts some of the rock. This molten rock, or magma, is lighter than the surrounding solid rock layer, so it rises through the mantle. The magma then escapes through vents in the Earth's crust, causing volcanic eruptions. Now above ground, this magma is referred to as lava, and it can reach temperatures of over 2,000 degrees Fahrenheit. In addition to lava, volcanoes may erupt with searing hot gas formed in the mantle. In a phenomenon called pyroclastic flow, this gas, combined with hot ash, can race down the sides of a volcano as fast as 100 miles per hour, burning everything in its path. To measure and classify eruptions, scientists developed the Volcanic Explosivity Index, or VEI. It considers various factors, such as the volume of lava, gas, and other emissions from the volcano, along with the height of the eruption cloud above the volcano's summit. The VEI scale begins at 0. Each successive measurement increases logarithmically, meaning that each magnitude is 10 times more powerful than the one before it. The VEI scale does not have an upper limit, but the most catastrophic eruptions measured thus far are categorized as VEI 8. These eruptions occurred thousands and millions of years ago. The most destructive volcanic eruption ever witnessed occurred in Indonesia in 1815. Mount Tambora, a large stratovolcano, erupted with a VEI measurement of 7. The blast caused earthquakes, tsunamis, and pyroclastic flows that decimated the land and took tens of thousands of Indonesian lives. The eruption even destroyed the top of Mount Tambora itself, turning the 13,000-foot tall mountain into a 3,640-foot deep caldera. While volcanoes are some of the most destructive forces of nature, they have also helped make life on Earth possible. Volcanic ash provides nutrients to nearby soil, making the land fertile. And lava, when it cools, hardens into rock and creates new landforms. With heat from the heart of the Earth, volcanoes have helped terraform the planet, making it the rich, dynamic landscape we see today.